All right, so welcome to another deep dive. And today we're going to be looking at Joshua Brett Tenenbaum
Oh, cool.
based on some really interesting stuff that we found on AIVIP.org. And this guy, I mean, he's really kind of unique, He's blending cognitive science with AI, trying to crack the code of how we think. So pretty amazing.
Yeah, he's not just trying to build, like a better chess playing machine or something.
Right.
He's really trying to go deeper. Like, how do we learn? How do we represent knowledge? That sort of thing.
Yeah. So let's start with, who I has Joshua Brett Tenenbaum.
Mm-hmm.
AIVIPs, they tell us he's a professor at MIT, but what else? Like, what's his background? What kind of led him to this really unique intersection of cognitive science and AI?
Well, it looks like even early on he was kind of drawn to math and science, but also just the whole mystery of the human mind.
Yeah.
So he ended up studying math and computer science at MIT, but you can tell from his work there's always this underlying question, how do our brains work?
So it's not just about the technology itself, it's how do we use it to understand ourselves better?
Exactly.
Which I think is so cool.
Mm.
And AI VIPs mentioned some pretty big names too as mentors.
Mm-hmm.
Steven Pinker, the linguist.
Oh, wow. Yeah.
Even Michael Jordan, who's huge in machine learning.
Yeah. I mean, that must have really influenced his thinking.
Absolutely.
Right.
Being exposed to those kind of thinkers. I mean.
Yeah, you can just imagine dinner table conversations, right?
Right. I mean, it's wow, thinking about the mind, not just from a philosophy perspective, but how can we model it? How can we build algorithms that mimic that?
Yeah. Yeah.
So that kind of brings us to, I guess, one of his big contributions, the whole Bayesian brain thing.
Right, the Bayesian brain.
And I'll admit, the first time I heard that term, I was like, whoa, this is going to be way over my head.
Yeah, it sounds intimidating.
It does.
Yeah.
But once you kind of break it down, Bayesian inference is actually pretty intuitive. I don't know. What do you think?
Oh, yeah, for sure. It's all about probabilities, It's how we update what we believe based on new information we get. You have this hypothesis. Let's say it's going to rain today.
Okay.
You see some dark clouds.
Right.
Okay. Maybe a little more likely to rain now.
Yeah.
You feel a raindrop.
Yeah, it's going to rain.
Okay. Even more certain, right?
Mm-hmm.
So you're constantly taking in this new information.
Adjusting.
Adjusting. Exactly.
So our brains are doing all these little probability calculations all the time without us even realizing it.
It's kind of wild when you think about it, right?
That's what he's saying.
Yeah.
And Tenenbaum says that's essential to how we learn and make decisions.
Yeah.
And he's taken that and applied it to AI with something called Bayesian program learning, BPL.
Yeah, BPL. I mean, this is where it gets really interesting, I think, because it's kind of a different approach to a lot of AI that we see today, Especially with deep learning.
Right.
Which needs tons and tons of data. BPL is how do we learn from just a few examples? Like a kid learning a new word.
Yeah, I was just going to say, you don't have to tell a kid 1,000 times this is a cat.
Right.
They see a couple cats and they're like, okay, I got it.
Hmm?
But how does BPL do that? How do you build that into a machine?
Well, it's about building these models, probabilistic models that can represent these concepts in a very flexible way. They're not rigid.
Okay.
They can change and adapt based on new information. Kind of like how our own understanding of the world constantly evolves, right?
Right. It's not just feeding a machine a ton of data and hoping it figures it out. You're kind of giving it more of a framework for understanding.
Yeah, more building up knowledge from the ground up.
Right. So that's huge, right? If you don't need these massive data sets for AI to be effective.
Oh, it's a game changer, potentially.
Yeah. That's why they're highlighting him on AI VIPs. But okay, before we get too carried away with the potential, let's talk about what this looks like in practice, because the article did mention some specific applications, right?
Yeah, I mean, his ideas are being used for things like object recognition, scene understanding. But one that's really fascinating is intuitive physics, how objects behave in the real world.
Intuitive physics.
Yeah.
Can you give me an example of that?
Sure. Imagine you drop a ball. You know what's going to fall to the ground, right? You don't need to solve a physics equation to figure that out. It's common sense. But for a machine, that's not so simple.
Yeah, that's true.
We take for granted our understanding of physics.
We do, yeah.
So he's trying to build these AI systems that can learn these basic physical principles, and not by programming in equations, but by observing the world.
Oh, so how a child would learn.
Exactly, like a kid playing with blocks, watching things fall.
That's much more intuitive.
Yeah, exactly. Yeah, and that actually ties back into this idea of hierarchical Bayesian models. Because, our knowledge isn't just this flat collection of facts. It's like organized. It's structured, like layers of abstraction. It's like, a robin is a bird, which is a type of animal. Each level of that hierarchy, you get like more abstract information.
Oh, that's interesting.
And Tenenbaum thinks AI needs this kind of structure, this hierarchy to really get the world.
Yeah, so it's not just like recognizing a robin. It's knowing like where it fits in the whole scheme of things.
Right, how its features relate to other birds, other animals.
Exactly, yeah.
And this applies to way more than birds, right?
Right.
This is how we understand language, how we navigate, how we learn new things. It's a fundamental principle of how our minds work.
The AI VIPs folks were really pointing this out as like a big difference from how, your typical neural networks work. And I gotta admit, this is where I get a little fuzzy.
Yeah.
Should you unpack that a bit?
So most neural networks, especially the ones used in deep learning, they're really good at pattern recognition, like sifting through tons of data, finding these subtle correlations.
Okay.
But they don't necessarily get the why behind those patterns.
It's like the difference between knowing the answer and understanding like how you got there.
Yeah. Like I could memorize a bunch of math formulas, get the right answer, but do I really understand the concepts?
Right.
That's the distinction he's making. For AI to be truly intelligent, you need more than just pattern matching.
Right.
You need like a deeper structured understanding, and that's what these hierarchical Bayesian models are trying to provide.
It's like you're building a foundation, not just like a surface level set of, data points.
Exactly, yeah.
So how does that actually play out? Can you give me some like concrete examples of how Tenenbaum's approach is being used?
Yeah. So one example is in object recognition. A deep learning system might need thousands of pictures of a cat to be able to recognize one. But with this approach, you could potentially teach a system to recognize a cat from just a handful of examples.
Wow.
Because it's not just matching pixels, it's building a model of like what a cat is. What are the features? How does it move? You know?
So it's like the AI is actually developing a sense of, I don't know, like intuition about cats.
Right. It's understanding it at a deeper level.
That's amazing.
And this can be applied to all sorts of things, from understanding scenes to predicting how objects interact, even like learning new concepts from very little data.
It's mind-blowing when you think about it. Okay, so we've talked a lot about the potential, but AI VIPs also brought up some of the challenges, especially around like computational complexity. What are the hurdles that researchers are facing?
Well, one of the big ones is that these probabilistic models, especially the hierarchical ones, can be very computationally expensive to run. They need a lot of processing power, especially as they get more complex.
So we need like bigger, faster computers to keep up with the demands of these models.
In a way, yes. But researchers are also working on making these models more efficient, right?
Okay.
So it's about finding that balance between, power and efficiency.
That makes sense. Now, I can't help but think about the bigger picture here. Tenenbaum's so focused on understanding human intelligence. Is he ultimately aiming for, like, AGI?
Oh, artificial general intelligence.
Yeah, the holy grail of AI, where machines are as smart as humans across the board.
Well, it's definitely a possibility. His focus on building AI that can, reason and learn like we do, that's very relevant to AGI. His approach could be a roadmap for creating machines that not only perform tasks, but like understand the why behind them.
That's pretty profound.
Yeah.
But AGI is still a ways off, right? We're not talking about robots taking over the world tomorrow.
No, not tomorrow. But things are moving fast, right? It's important to have these conversations now, to think about the potential impacts, both good and bad.
I agree. It's crucial to be prepared. Now, another thing that keeps coming up for me is the comparison between Tenenbaum's approach and the more like data-driven approach of deep learning. They seem like two pretty different ways of doing AI. Is it one versus the other, or can they coexist?
That's a great question, and it's something that's being debated right now in the AI community. Both have strengths and weaknesses,
Right.
Deep learning is amazing for pattern recognition, can handle huge data sets, but it can be kind of a black box, and it struggles with things that require common sense reasoning or understanding cause and effect.
So deep learning is like this super efficient pattern matching machine, but it might not always grasp the nuances of the real world.
Yeah, that's a good way to put it. On the other hand, Tenenbaum's approach, with its emphasis on cognitive models and probabilistic reasoning, it's great at capturing those nuances.
Okay.
But it can be computationally demanding, like we said.
So it's like they each have their own unique advantages.
Mm.
Is there a way to kind of combine them, get the best of both worlds?
Well, that's what a lot of researchers are exploring right now. Imagine a system that combines the raw power of deep learning with the reasoning and understanding of Tenenbaum's models. That would be something.
It's exciting to think about the possibilities. Well, I think we've covered a lot of ground in this deep dive. I want to make sure our listeners have had a chance to really, take it all in. So let's take a moment to reflect on what we've learned about Joshua Brett Tenenbaum and his vision for AI. All right, so we're back, ready to wrap up this deep dive into the work of Joshua Brett Tenenbaum. This has been pretty amazing, right? Like this journey through AI and cognitive science.
Yeah, no, it's really fascinating stuff. And there's just so much to his work,
Yeah.
But hopefully people listening have a better idea now of why, he's considered such a visionary in this field.
Right, like he's not just building smarter machines. He's really trying to figure out, like, what does it even mean to be intelligent?
Exactly, to think, to learn.
And that's something that, like, resonates with everybody, right? I mean, whether you're like a computer scientist or just somebody who, you're fascinated by the human mind.
Mm-hmm.
It's like he's asking some really fundamental questions about who we are, how we see the world.
Yeah, it's really about the nature of intelligence, the connection between our brains and the machines we build, and, what's it going to mean for society, all this AI stuff.
Speaking of impact,
Yeah,
I keep thinking about, like, all the potential uses for his ideas.
Right.
AI VIPs mentioned, like medical diagnoses, robotics, even education.
Yeah.
It seems like it could change so many fields.
I mean, imagine a world where AI is helping doctors make better diagnoses,
Right.
or robots can learn new tasks super quick, safely in really complex situations, or even like education, right? Where it's personalized for each student. That's the kind of stuff that Tenenbaum's work is pointing toward.
Yeah, it's like we're on the edge of this, I don't know, like this new era of AI where it's not about replacing us, it's more human-centered, focused on understanding and like augmenting our abilities.
That's a great way to put it, yeah.
It's not about, machines becoming super intelligent and taking over.
Yeah.
It's about how can they work with us, using their strengths along with ours.
Right. To solve problems, to understand the world better.
Exactly. Well, huge thanks to AIVIPs.org for all the insights that led to this deep dive on Joshua Brett Tenenbaum.
Yeah.
To everyone listening, we hope you keep exploring this world of AI and cognitive science. It's constantly changing, always something new to learn. So until next time, keep those minds curious.